Hello, and welcome to this hands-on lab session on setting up a secure network using Cisco Packet Tracer. Today, we will simulate a real-world scenario with routers, switches, and servers while learning key security concepts using Cisco devices. Let us begin by reviewing our network topology. In this topology, we have devices operating in both the internal and external networks. Currently, services in the internal network are accessible from the external network, posing a significant security risk. Let us verify the current situation. Verifying SSH access from the external network to our router. As observed, SSH access is possible from the external network. Verifying pinging from external users to internal network devices. Now, let us check access to internal HTTP services. As demonstrated, all devices and services in the internal network are accessible to external users. This exposes several vulnerabilities. Problem identification. We've identified the following security concerns. 1. External users can ping internal devices. 2. External users can access the router via SSH. 3. External users can access internal web services. 4. Internal web servers can SSH into the internal router. What's the solution? To secure the internal network, we'll implement access control lists, ACLS. Let us start with the first issue. Block external users from pinging internal devices. Step 1. Blocking external users from pinging internal devices. To begin, we'll configure an ACL on the router to deny icmp traffic from the external network. Configuring the ACL. Access list 100 deny icmp 192.168.2.0.0.0.255.192.168.1.0.0.0.255. Access list 100 permit IP any. Applying the ACL to the external interface. Interface serial 010. IP access group 100 in. Verifying the ACL by attempting to ping internal devices from the external network. Success! External devices can no longer ping internal devices. Prevent SSH access from external users. Step 2. Blocking SSH access from external users. To block SSH access from external users to the router, we'll create a new ACL. Access list 101 deny TCP 192.168.2.00.0.0.255 host 192.168.1.1 EQ22. Access list 101 permit IP any. Applying the ACL to the external interface. Interface serial 0110. IP access group 101 in. Verifying SSH access restriction. Great! SSH access from the external network is now blocked. Block access to internal HTTP services. Step 3. Blocking access to internal HTTP services from external users. Next, we'll secure internal web services by blocking external access to HTTP. Creating ACL 102 to deny HTTP traffic. Access list 102 deny TCP 192.168.2.00.0.0.255 192.168.1.20.0.0.0 EQ80. Access list 102 permit IP any. Applying the ACL to the external interface. Interface serial 0110. IP access group 102 in. Verifying HTTP access restriction. Success! External users are now restricted from accessing internal HTTP services. Block internal SSH access from web server to router. Step 4. Blocking SSH access from the internal web server to the router. To prevent SSH access from internal web servers to the router, we'll create a new ACL. Creating ACL 103 to block SSH traffic from a specific host. Access list 103 deny TCP host 192.168.1.2 host 192.168.1.1 EQ22. Access list 103 permit IP any. Applying the ACL to the internal interface. Interface gigabitethernet 000. IP access group 103 in. Verifying the new ACL. Success! SSH traffic from the internal web server to the router is now blocked. Verify configuration. Step 5. Verifying the configuration. To ensure all changes are correctly implemented, check the running configuration. Show running config. To verify ACLS, use. Show access lists. Test by attempting ping, SSH, and HTTP access from external users to ensure restrictions are in place. Save configuration. Step 6. Saving the configuration. Once verified, save the configuration to ensure it persists after a reboot. Write memory. Or copy running config startup config. Conclusion. In this session, we've successfully secured our network by 1. Blocking external users from pinging internal devices. 2. Restricting SSH access to the router. 3. Blocking external access to internal HTTP services. 4. Preventing internal SSH traffic from web servers to the router. Thank you for participating in this lab session. If you found this content helpful, please like, share, and subscribe to the channel. Feel free to leave comments or feedback below, and stay tuned for our next session.